You've spent endless hours building your model, and now you're ready to take it to the next level with texturing. You could use Cinema's built-in body paint tools, but yeah, let's be realistic. So what are the alternatives? There are several different solutions out there, but the way I see it, there's only one truly outstanding option, and that's Substance Painter. If you're a long-time viewer of the channel, you know that I'm not a big fan of Painter's cluttered and convoluted UI. But here's the thing, as frustrating as Painter might be, it's also an incredibly powerful tool capable of producing amazing results. So until another tool comes around that addresses all of Painter's issues, you're just better off learning the tool and taking advantage of its toolset. That's where this video comes in. Instead of struggling to figure out the entire texturing workflow and its pitfalls on your own, why not learn from someone who has already navigated that annoying process? So in this video, we'll go through the basic things you need to know to start texturing your models in Painter. I'll be using Cinema 4D alongside Painter, but everything I'll show you here applies to other 3D applications as well. So if you're using another app like Blender, you can still follow along just fine. So let's get started. Before importing our model to Painter, we need to do a little bit of prep work. First, we need to make sure we have our UVs set up. Painter does have automatic UV unwrapping, so in theory you could skip this step entirely, but this approach has some drawbacks. For example, you might run into a scenario where the UVs are laid out in such a way where you can't draw what you want in the 2D view. So with that in mind, it's better to just have your UVs laid out the way you want them to, rather than relying on Painter's automatic tools. This is also the point where we get to make some important decisions, so we won't end up with a gazillion textures. For example, we wouldn't want to have 4 different sets of textures for every single part of our model. Let's take as an example the action buttons. If each button occupies its own UV space, we would end up with a diffuse, normal, height, and roughness map for each one of them. That means 16 textures just for these 4 buttons alone. That's way too much data. And the same thing applies to other parts like the 2 joysticks. If we have them set up separately, that means we will end up with 8 textures. So here's how I've approached things when UVing the controller. The action buttons occupy 1 UV space, and the same goes for the 2 joysticks. One is on top, the other one at the bottom. Basically, however many parts fit logically together in the sense that they share the same material properties, they are grouped into 1 UV space. Which brings us to the second thing we need to take care of before importing our model to Painter, and that's material groups. Material groups are essentially an extension of how we laid out our UVs, and it's important to create them beforehand, mainly because of how things work inside Painter. In Painter, we don't see the object hierarchy at all. We will only see the material groups assigned to the different parts of our object. So if we don't have any, the whole object will be controlled by 1 material group. So if we delete all the materials and import just the geometry of the controller, notice what happens. We only have this 1 material group to work with, which will make things very tricky to set up because the controller has a ton of different types of materials. For example, the joysticks have this rubbery type of material. The action buttons, on the other hand, are made out of a grainy type of plastic. And if we go even further, the triggers and the dividers between them use yet another type of plastic. The dividers are smooth, while the triggers are grainy and a little bit rougher to the touch compared to the buttons. So trying to create all these different types of materials with just 1 material group is not the best way to approach this. So before starting the texturing process in Painter, I went ahead and created all the different types of materials in Cinema, and I've also assigned them to the corresponding parts. As you can see, the materials are nothing special, just the default redshift material with reflections turned off. At this point, we don't really care how the material looks, we're just interested in visually seeing all these different groups on the model. It's definitely more materials than you would have expected, right? And this is where you can apply your own criteria based on the requirements of the project. So if you want to, you can just reduce the amount of materials even further. You could even try and fit everything into one UV map. It's up to you really. I'm just showing you how I would approach things if I had to use this controller as a hero model. The last thing we could set up is vertex colors for all the parts of the controller. We can use these to create an ID map later on in Painter. It's not necessary, but it comes in handy in several occasions. For now, let's forget about this part, but keep it at the back of your mind because we'll come back to it in a bit. So here's where we're at so far. We've laid out the UVs and we have also created the material groups for all the different parts of the controller. Now let's talk a little bit about the model's geometry. What should we do when we have subdivision surfaces? Painter doesn't recognize those at all, so we have two options. We can either hit C and make the object editable and export that to Painter, or we can leave the object as is and bake the subdivisions in the exporting step. That means that in Painter we'll be working with the high-res mesh, and in Cinema we will still have the more flexible hierarchy where we can enable or disable the subdivision surfaces. Again, this is something for you to decide based on the requirements of your model. For example, if your object will only live inside Cinema, you can bake the subdivisions in the exporting process. But if you're going to use the model on another 3D software like Unreal, it's better to bake the geometry right from the beginning. For the controller, I decided to bake the subdivisions from the get-go, so the model is exactly the same inside Painter and Cinema 4D. We're now finally ready to export our model. Let's go through that process together. My format of choice when working with Painter is FBX, and thankfully there's not a lot of options we have to fiddle with. We can disable most of what we see in the export dialog. We don't care about lights, cameras, splines, or instances. We also don't care about animation. The only thing we're interested in is the geometry and material options. As I've mentioned earlier, if we have subdivision surfaces on our objects, the option we want to pick here is to have them baked. Keeping subdivisions as generators won't work in Painter, they will be completely ignored. Let me quickly show you with a cube inside a subdivision surface. Our cube looks like a sphere inside Cinema, but when I import it into Painter with the generators option enabled, it just looks like an ordinary cube. If we export the model with the baked option enabled, we get the same result as in Cinema. So when working with Painter, always choose to have subdivisions baked. Now the other thing we need to take care of is vertex colors. If we're going to build an ID map in Painter, we need to have this option enabled. We'll go through that process at the end of the video, but you can just keep it enabled for now even if you don't have any vertex colors. It won't make a difference. And finally, we have the material options. We need to make sure that this option is enabled, otherwise the materials we see in the material editor won't import at all. Since our materials are simple, we don't care about any of the other options, so we don't have to bake the materials or embed the textures that might be inside them. We also don't have to worry about the substance materials option. And that's it. We're now ready to export the model and start working with it inside Painter. To load up the object, we go to File, and then New. We get a scary pop-up with a gazillion different options, but in most cases we don't have to do much here other than selecting the object we want to load. Make sure also that you're using the right template. In most cases, the default PBR metallic roughness option is the one we want, but if your asset is meant to be used in Unreal or Roblox or some other engine, it's better to pick an option that fits these engines. As for the document resolution, it doesn't really matter. We can always change that later on. I always go for the 4K option, but if you forget to switch to that, it's not the end of the world. I'm also changing the normal map format to OpenGL. One thing to note here is that if you already have some textures, for example when you're working with a scan, you can load them up in the Import Baked Maps section. That way it's easier to select them later on from the Materials dropdown. I don't change any of the color settings. Everything is set up to work with OpenColor IO, so we're good to go on that front. And that's it. We're finally ready to work with our object. As you can see on the top right of the screen, we have all the materials we created inside Cinema. So all we have to do now is start adjusting them. The layers window right underneath the texture set list is the area where we build our materials. It's context sensitive, so it will change depending on what's selected in the texture list panel. Let me just give you a quick example with some super simple material adjustments. When I click on the joysticks material, we see the properties of that material. It's a fill layer that has a yellow color. When we click the top shell, we get to see the properties of that material, which is a layer in blue. Of course, we can stack as many layers as we want. Layers in Painter pretty much work the same way as layers in Photoshop. We can create masks, we can mix layers using blending modes. Most of the stuff we're familiar with in Photoshop are there. The only difference being that each layer can control more things than just color. So with each layer we can also affect normals, height, roughness, metalness, and SSS. And of course, we can disable some of these properties if we want to. Now let me show you something that's really important if you want to take advantage of Painter's generators. These can create all sorts of effects like dirt or wear and tear. In order for these effects to work though, Painter has to understand how the different surfaces look. And we do that by baking some maps. We need to go to the texture set settings, and if we scroll down, there's a Bake Maps section. Let's click on that, and now we have a new window where we can select what we want to bake. We can choose the type of maps we want to bake, and also whether we want to bake just the selected material or the whole object. Even though I haven't set up vertex colors, let's keep that selected, and let's also keep the thickness map selected too. That's used for subsurface scattering. Let's also go for higher res textures. Let's do 4K. And once we press bake, Painter will go through that process and it will create all the maps for us. Once it's done, we can press return to painting mode and we're now ready to use the generators. Let's tweak the top shell. I'll select the shell material and I'll create a fill layer as a base. Now let's say that we want to add some wear to the surface of the shell. I'll create a new fill layer, add a black mask, and with a mask selected, I'll add a generator. The generator will essentially control how the mask looks. And now let's pick the metal edge wear. And just like that, we have a nice weathering effect on the edges of the surface. And we can control pretty much everything. The amount of wear, the color, how the weathering looks, everything we might need can be adjusted. So keep that in mind. When you want to create these types of effects, including dirt or some calculations that might need AO or other types of surface information, don't forget to bake the appropriate maps for your object. The last thing I would like to show you before we move on to the exporting dialog has to do with SSS. To work with it, we have to jump through several hoops. We basically need to adjust things in 3 different places. It's definitely not the most intuitive workflow. So let me load up another object that's a little bit simpler. Okay, first off, we need to bake the thickness map for the object. Otherwise, SSS will not work. The process is exactly the same as before. We just go to the texture settings and bake the maps. Now that we have that done, we also need to make sure that we have SSS available as a slot in our material settings. Currently, as you can see, there's no SSS option there. So let's go back to the texture settings and add SSS as another channel. It's called scattering. And now if we go back to our material, you will notice we have a new scattering slot. We're almost there. The final place where we need to enable it is in the shader settings. Let's select that, and if we scroll a little bit, we'll find the subsurface scattering option that we need to enable. Easy, right? We only had to go to 3 different places to deal with one option. And we're not really done yet. Notice that our object hasn't really changed. There's a couple more things we need to do. So let's go to the scattering channel and let's set it all the way to 1. White means that SSS will have a full effect, and black means that there's not going to be any scattering visible. And now that we have that, we can go back to the shader settings and disable Use Translucency Channel as Scattering Mask. Now subsurface scattering will take effect. We can adjust the subsurface scattering's look by adjusting the scale, and also by adjusting the strength of the effect in the materials channel. Painter's Manual also suggests turning on these shadows for the effect to look more realistic. To do that, we need to go to the display settings and enable shadows. If you want to, you can also enable the scattering color channel to further adjust the color you get out of the scattering process. And that's pretty much it. It only took us like 50 clicks to get there, but at least we have the result we're after. Alright, now let's say that our object is done and we're ready to export the textures. The process, thankfully, is nothing too complex. We just go to File, Export Textures, and then we can just pick the output path and hit Export. The one thing I would like to show you here is the Output Templates tab. There we can either create our own custom settings or pick from the ready-made ones. Since there's already a Redshift preset, I just pick that. It will take care of several things, for example, the naming of the textures. In this case, in the normal and height map, we will have the color profile written at the end of the file name. This is a nice little reminder when setting up the materials in Cinema, so we don't forget to use raw as the color space. There's also other settings like using 16 bits for the height and normal map, and so on and so forth. Once we have that set up, we can just go back to the main settings and hit export. And that's that. But don't worry, I did not forget, we have one more thing to talk about. Think of the ID map as a quick way to select a specific area of the model and apply different properties to it. It's basically a way to create masks that can be used in our layers. Let me give you an example, and let's go with a very simple model. Here we have 3 spheres. The first 2 have the same material, while the third one has a completely different one. The first 2 spheres share the same UV space, while the third one has its own. Let's say now that we want to draw something on the top right sphere without it affecting the other one. There are several ways we could approach this, but one way of handling things is through the ID map. So what we need to do here is give the first and second sphere a different vertex color. As a matter of fact, let's go ahead and give all spheres different colors. With all of them selected, right click, and on the other tags section, pick the vertex color tag. Now let's go through each vertex tag and edit the color. Double click to get the vertex color options, and let's pick purple for the first sphere. Hit apply all, and now sphere 1 is ready. Let's repeat the same process for the other 2. I'll give green to the second one and yellow to the third one. Perfect. We're now ready to export to Painter. Like before, we need to make sure that we have our vertex colors and materials checked. And here's where the magic happens. Let's go to the Bake Maps option, and in the ID section, we can pick the vertex colors we created in Cinema. So now, even though the 2 spheres belong to the same material, we can further separate them through the ID map. Let's do that. Let's create a fill layer and pick a red color. So now what we want to do is to draw something that will stick only to the top right sphere. If I create a new layer and start drawing, notice what happens. Both spheres will be covered with my brushstroke. But with the help of the ID map, we can easily circumvent that. Let's add a black mask to our layer, and with a mask selected, let's add a color selection. And now it's just a matter of picking the top right sphere with a color picker. And just like that, our brushing is limited to that sphere only. As you can see, even though our two spheres share some of the same properties, we can further separate them through the use of ID maps. It's something that definitely comes in handy, so even if you think you won't need it right now, you will in the future. So just mark this part of the video and reference it when the need arises. And with that, I think we're done with the basics of texturing. As you can see, the texturing process requires quite a few steps, but once you do this a couple of times, it's going to get easier and faster with each try. There's a ton of stuff we can do with Painter, so if you have a specific question in mind, just let me know in the comments below, and I'll try to cover it maybe in a future video. Take care, and I'll see you in the next one.